Good morning. Welcome back. So, yesterday's class we did queue delete operation, and I can see many of them are having a lot of doubts. See, queue is a data structure. The operations performed by the queue are NQ and DQ. So, NQ and DQ are not data structures. They do not follow any principle like first in, first out, last in, first out. Because when I say in and out, it includes both the deletion as well as the insertion operation, right? So, insertion and deletions are the operations performed in a data structure. The operations itself is not a data structure. Getting it? So many had a doubt that okay, like rare insertion NQ is LIFO and DQ is FIFO. It's not like that. A queue is a data structure which follows the first in, first out principle, and you cannot change it. Like it has to be followed that way only. So you cannot randomly, many felt that I will randomly delete the third element or the second element. It is array based implementation, but then you cannot directly access any element. You have to follow that order only, and it follows the first in, first out principle only. That is, the element which entered the queue first has to be the element which goes out of the queue, and it will go out from the front and it will insert from the rear. You cannot change it. I cannot go on deleting from the rear side. You cannot do that. Rear is only for insertion, and front is only for deletion. Like only from the front I can delete, only from the rear I can insert in a linear queue. That is what I try to tell many times, but then many of you had a feeling that NQ and DQ itself are data structures wherein it one is LIFO and one is um, first in first out, the other one is last in first out. Because when I say in and out during NQ operation, I never delete any element. So it's only the insertion. It's an operation performed in a queue, where queue is a data structure which follows the first in first out principle. Queue is a data structure, or is a linear data structure wherein the insertion happens from the rear and the deletion happens from the front. It's like a normal queue only. You can see that the first person who entered would be the first person to go out of the queue, right? And the restriction is randomly. Okay, it's like a human queue. You will say I don't want to stand, I can go out. But here it does not happen. Once you enter the queue, you will have to wait for your turn to go out. It will not be like okay, I want to move out, I will move out now. It does not happen that way. So the insertion happens from the rear. Rear is a pointer which keeps track of that. So insertion happens from the rear, and rear starts from inserting the element first in the 0th location, then the first 2, 3, 4 up to n minus 1 locations. It will not start from n minus 1 towards 0. The order of insertion will start from the first element would be inserted at the 0th location only, and then you go on incrementing it. It will go and stop till the n minus 1 location. So once I enter the element in n minus 1 location, queue becomes full. I will not be able to push in or enter another element inside the queue. So that is called NQ operation. It's an operation performed on a queue data structure. NQ is not a data structure, it's an operation performed on the queue data structure which follows the first in, first out principle. So if I say 0 to n minus 1, I can delete the n minus 1th element only when I delete all the other elements before that. Starting from 0 to n minus 1, I have to always start from the front and move to the rear. You cannot start from rear and move to the front in a linear queue while deleting. Hopefully you've understood this. Like I need to start when I delete, I will delete first a 0th element, and then I will move on to the first, second, third, then only till the n minus 1. Randomly, I cannot say I want to delete the fourth element when the second and the third element are present. That is not possible. It has to be sequential deletion only, starting from the front to the rear. Whereas insertion also, the first element inserted would be from rear, but then the inserted would be starting from 0, 1, 2, 3. See, behind one another the element gets pushed. It's like first element is 0 when there are no elements, and then the second element will not go back to 0th location and the 0th element gets pushed back to 1. It does not happen that way. It will be placed behind the 0th element, then behind that, like that it goes on. When you are deleting also, the first the 0th element will go out because it entered the queue first. So first in, first out, that is the principle which is followed by it, and you cannot change it. Nor NQ, DQ or data structure which follows certain principle. When I say Q is a data structure which follows this principle, that is the insertion happens from the rear and deletion happens from the front. That is, the first element entered should be the first element going out of the queue. Random deletion, that is, I cannot directly access any other element in between and delete if there are any elements before that. So front is a pointer which keeps track of the element which is in the queue, that is, which is there in the queue to be deleted, and rear is a place pointer which keeps track of the last inserted element. So if you want to insert one more element, you have to check for rear, and if rear is not equal to n minus 1, it means that there is no overflow condition. Then you need to increment rear to point to a blank location, and then you can insert an element over there. The same thing happens to front. Check for the underflow, that is, there are any elements in the queue or not. If there is an element in the queue, then first you delete the element and then increment front so that it moves to the next location, because the elements do not shuffle or reshuffle or reallocate. That is, if I delete an element in the 0th location, the element in the first will not move forward to the 0th location. It stays there only. So front will move forward to the element at the location 1. Getting it? Hopefully you have understood this. When I say array based implementation, I will use the index of the subscript values, and then the size is fixed during compilation time. But then as arrays, I cannot randomly access any element while insertion as well as deletion. That is, if I am inserting element, it has to start from 0 to n minus 1. I cannot say that I need to insert an element at the location 4. No, unless and until you have elements filled before that, that is from 0 to 3 is filled, then only you can insert an element at 4. Otherwise you cannot. So I think it is very clear now. It follows the first in, first out. When I say in and out, it includes both insertion as well as deletion. Insertion is NQ and deletion is DQ. These are the two operations which are performed on the queue. So yesterday's class we did I showed you how exactly the DQ operation works. The first thing is you need to check whether any elements in the queue are not. If there are no elements in the queue, then you will say empty queue or underflow. And then if there are elements in the queue, first you delete the element. That is, first take out the element which is there at the location front, to which the front is pointing to, or the location front, and then you check whether that was the last element in the queue or not. If it was lost, how will you know that was the only element in the queue? When rear and front will have the same value, that is, if both are pointing to the same element, it means that that was the last element in the queue. You need to reposition or reset the front and the rear pointers to -1 because the queue becomes empty. Otherwise, you have to only increment the front so that it will point to the next element in the queue, which has to be deleted whenever DQ operation is performed, because the elements will not shift. The pointer, you need to shift it to the next location. Fine. Please go through this again and don't get confused between the operations and a data structure. Data structure is different, operations are different. Operations are nothing but what you can do on the data structure. The data structure is something which you cannot change the working of it. You have to follow that way only. You cannot say I want to do it this way. When I say queue, it has to follow the first in first out. When I say stack, it will follow the last in first out only. It will have only one end. Both insertion and deletion happens from that end, whereas in a queue the insertion happens from the rear and the deletion happens from the front, that is two ends. So that is how it works. Please have a look. Now we'll write a program to perform queue operations. After this, I'll go with the algorithm. Fine. In the meantime, you can try writing the algorithm on your own, so it will be easy for you to remember also. And then it's a commonly asked question in the exam. Please write this along with me, so that make a note of this along with me, as this happens to be your practical program also. Write a program to perform queue operations. Fine. Write a program to perform queue operations. So what are the operations on the queue? NQ and DQ. Along with that, I will print the elements of the queue also at that given point whenever you call the print function. So we'll be starting with the hash include iostream.h hash include conivo.h hash include ctype.h, because I will be using a function to lower, that is, which will convert a character passed to it to a corresponding lowercase, and if you pass a lowercase character, it remains as it is. So that's a built-in function of ctype.h header file. That is why I am going to include that header file. Hash include process.h, that is for exit function, and then I will use hash size. Let me say the size is 10. After this, or after my hash include statements, I will be starting with my program. Like this is the starting of the program with my class. So class is a keyword. All the keywords are written in lowercase only. Class, let me say Q is the name of my class. Oh, after that, open the bracket, and then if I don't specify anything, still it will become private. Private, public, protected are the access specifiers of the class, where you write the data members and the member functions of the class, depending on which they will be accessible from outside. So I'll say private. Private data is not accessible from outside, nor it gets inherited. It is accessible only to the member functions declared in the class. So private and colon is the syntax. Your colon is a must there, and then you cannot have a semicolon over there. You need to follow the syntax of a language in order to write a program and execute it. So I'll say int queue of size. Okay. Then I'll say item I front. So these are my data members of the class which is declared in the class which is declared in the private section of the class. Int q of size item I front and red. These are my data members. Next I will write my member functions in public, because if I don't write in public, I will not be able to call it from outside. Getting it? Otherwise, you have to do indirect calling. Instead of complicating the matters, let me write it in public so that I can directly call it. Public, in public, let me start with Q, which is a constructor, then void NQ. Why do we need NQ? To insert an element, because when I say DQ operation, I should first I should have an queue with some elements, then only I can do the DQ operation properly. Otherwise, every time I try to delete an element, it will show me empty queue. So in order to do that, first I need to insert element into the queue. That is performed by NQ operation, and it is not going to return any value, and I am going to pass an integer argument to it when I call it. Getting it? And then what is this called? This is called the function declaration. I'm going to declare the function inside the class, and I'm going to define it outside. The other one is void DQ. Why do I need DQ? To delete an element from the queue. Then void print, which I'm going to print some elements, and then this ends my class. That is class Q, and then in that I have different data members. These are all data members of the class, member functions. Int q of size item I front and rear. These are the data members of the class which is declared in the public section of the class. Then I have in the declared in the private section of the class. Then I have in the public section q, void nq, void dq, and void print. All these are the member functions of the class, and then I am closing my class here. So this is my class q. After that, I'm going to define it outside. Yes. How do I do that? Return type of the function, the class in which it is declared, or the name of the class to which it belongs to, scope resolution operator, and name of the function. Since Q is a constructor which does not have any return type, when you don't have any constructors or functions which are declared in the public section of the class and they do not have any return type, not even void. So I will say the name of the class is Q, and then the scope resolution operator. So I will start. What am I going to do here? I am going to give the initial values of front and rear to -1. That is, I cannot declare and initialize in a class. Declaration and initialization is not allowed in this part of the class. It will give you error. Either you have to do it in a constructor or you can do it in a member function. So let me do it in a constructor. Front is equal to -1 in an empty queue. Yes. And then I have Rare is equal to -1. Since the queue is empty, I'm going to begin with front and rare will have the values -1. After that, let me write my NQ function. Okay, Q is done. Let me write my NQ function. How do I write it? Void, return type of the function is void, name of the class to which it belongs to, or the class in which the NQ is declared is Q. So you need to write it. This is a commonly asked question. They will ask you the declaration and definition of a function inside the class or outside the class. So I have declared the function inside the class over here, and I'll be defining it outside. The definition of a function will have two parts. One is the function header, the other is the function body. So void q scope resolution operator, and then it takes in an integer parameter. Let me name it as item. So what is that? Item, int item is the formal parameter. The parameter in the function header is called the formal parameter. Then first what I have to do. So here I will not have any C out or C in statements. Like I will not be taking in the value which has to be pushed in the queue, because I would be passing it from the calling function to the call function at the time of the function call. So in main I will ask the user to enter it, and when I call the enqueue function, I will pass it as an argument to it. So first thing, when I do enqueue, what are the things you need to keep in mind? First, I need to check whenever I'm inserting an element, I need to check whether there is any place in space in the queue or not. So basically I'm checking for the overflow condition. Check for the overflow condition. How do I do that? How do I check for the overflow condition? If rare is equal to size -1, right? It means that there is no space in the queue and queue full or overflow. If rare is double equal to size -1. What is size? The number of elements, the maximum number of elements in the queue. So 0 to size -1 is equal is nothing but that many number of elements. Here I have given the size is a constant which has the value 10 assigned to it. So 0 to 9 is nothing but 10 elements. If rare is size -1, I can say C out and Q full Q full overflow. Yeah. After that, I will say return. Then I will close my bracket here. So if this is like if rare is size -1, that is when rare has reached the max is pointing to the last element, then there is still no more space in my queue, so I should write C out ender queue full or overflow ender and return. If this is not true. That is, the queue is not full. I do have some place in my queue, so I will write it in else. If and else. In else, let me write first thing what I have to see. If that is not true, like I have place in my queue, that is rare is not equal to size minus 1, then I have to check whether the element is the first element to be inserted into the, what you're going to check, whether the element is the first element to be inserted into the queue. This you're going to check if the queue is not full. How will I do that? If front is equal to -1. Front will be -1 only in case of an empty queue. So what I will do, I will reposition the front and the rear, right? If that is not true, I need to reposition front and rear, because if it's the only element, then front and rear should point to that element, not only rear, front also should point because it's the first element entering into the queue. So I'll say our rear is equal to 0, is equal to 0. So rear and front are equal to 0 here. Getting it? Then I will close my if here. If the element inserted is the first element to be inserted, then how do you check it? If the queue is not full, then you will check whether the element is the first element to be inserted. How will you check that? If front is equal to -1, then reposition the front and rear. Rear becomes 0, front becomes 0, and then you will insert. Otherwise, suppose if it is not the first element, there are already elements in the queue, then what will I do? I just have to increment the rear pointer, rear plus plus, and I will end. So now I have not closed the outer else, I have closed inside else. You have two, like when there is space, when the queue is not overflow, either the element inserted can be the first element or it may not be the first element. If it is the first element, you need to reposition the front and the rear to 0 and then insert. Otherwise, you have to just increment the rear pointer, because insertion happens from the rear. Then after that, I close that else also, but the outer else is still open. I need to insert queue of rear is equal to item. Where do I get this item? I got it from the calling function. I have passed it as an argument here, and that gets substituted in the queue of rear location. Getting it? And then for the user's benefit, I will say cout element wait, item is successfully inserted into the queue. Fine. So what am I doing here? After that, repositioning everything, otherwise rare. So rare will have value now. First one, rare, already is full, so it will go back. It will not increment. In the second case, either it will have 0 if it is the first element to be inserted, or it will be incremented by 1, and then at that location, q of rare is equal to item. Where to get the item? I am passing it as an argument from the calling function during the function call, and then for the user's benefit I'm writing cout element would be printed as it is because I have put it in double quotes. Item without double quotes, though whatever is the value stored in that variable would be printed over there, is successfully inserted into the queue, would be again printed as it is since I have written it in double quotes. So after this I don't have anything to do. So I will close my else and then I will close my function. So this is my enqueue function. Hope you have understood that. Check for overflow and then else. If the overflow is not true, I'll go to the else. In else again I have an if and an else over there. If it's the first element or if it is not the first element, and then I close it over here only, then the outer else gets closed here and then the function gets closed here. Okay, now I will be writing my dequeue function. How do I do that? Same return type, void the name of the class to which it belongs to, scope resolution operator, and the name of the function, and then there are no arguments, so the function brackets are blank. After that, the first thing whenever I am deleting from a queue is I need to check whether there are any elements in the queue or not. So check for the underflow condition. Yes, I need to check for the underflow condition first. Sorry, not unflow, it's underflow. Check for the underflow condition. How do I do that? In an empty queue, if you are trying to delete, how will you find the queue is empty? If front is -1, it means that the queue is empty. So I will say if is double equal to -1, then it is cout and queue empty. Underflow, then I will say return. If this is not true, that is, if the underflow condition is not true, I mean there are elements in the queue, so I will be writing it in else, right? In the else part, what will I write? First I need to take in the element. So item is a variable of the type integer which I have already declared. Item is equal to q of, why am I giving q of front here? Because the deletion happens from the front. So item is equal to q of front. So whatever is element is there at that location or at the index location would be substituted. That is, the value of RHS gets substituted to LHS. So whatever is the value at that location or the element at that location gets substituted to the integer variable item. After that, what I have to do after taking out, you need to check whether it was the last element in the queue which you deleted. Getting it? Check if it was the last in the queue which you deleted. So how do you do that? How do you check? How do you check that? If front and rear point to the same element, then it means that that was the only element in the queue. So if rear is double equal to front, so rear is equal to front, then it means that it was the last element in the queue. When there is only one element left in the queue, that time only rear and front will be pointing to that element. Otherwise, they'll be pointing to different elements. Rear would be pointing to the element which was inserted in the end, and front would be pointing to the element which will go out of the queue when you delete. So, if it is the last element, reposition the front and rear. So why is it? Because once the queue becomes empty, you cannot keep it as 0 or whatever value they are pointing to. You need to make it as -1 because the queue becomes empty, because you deleted, which was the last element in the queue, already got deleted. So you need to reposition the front and the rear pointers. So what will I do? Front is equal to -1, rear is equal to -1. So I'm doing it. So front is equal to -1 and rear is equal to -1. If this is not true, like if suppose it is not the only last element in the queue, there are some more elements in the queue, then what should I be doing? I should be just incrementing the value of front, because it should point to the next element which needs to be deleted, since after deleting the element did not reshuffle or reallocate. You need to delete it. It will not go, like you need to put front to the next element, whereas the elements will not take the place of the deleted element. After this, let me write down C out C out element item deleted successfully from the okay. After that, what should I be doing? I should close my else. Yes, this is the end of my else, and this is the end of my program. The else, outer else, and the inner else. We'll go through this again. Check for the underflow condition. I'm not passing any parameters to it, right? I'm not passing any parameters to it because it doesn't need. I'm not inserting, I'm deleting. So I don't have to pass any parameters. If front is equal to -1, the queue is empty. So you give an underflow condition. You cannot delete an element when the queue is empty. Otherwise, what you do, first you delete, then you will check whether that was the last element you deleted. If rare is double equal to front, it means that it was the last element which you deleted from the queue, and front is reposition the front and rare, it becomes -1. Both front and rare becomes -1 because in an empty queue front will have -1 value. Else, like suppose you do have some more elements to delete, that was not the last element, you just increment front so that it will point to the next element in the queue which needs to be deleted whenever the delete operation or queue delete is performed. Then I'm just printing the element directly as it is. Item is the value which got deleted successfully from the queue, and then I closed my outer else and then the function. So this completes my dequeue function. Then I'm left with my what? I'm left with my print. So let me say void name of the class is queue scope resolution operator print does not take any arguments. So I will say print the elements of the queue. So I'm going to print the elements of the queue. Cout. Let me put an endl there. The elements of the R. Since I'm going to print multiple times, then I need to put it in a for loop for I. So I is already declared. I should start from front to the rear, right? Front would have point to the element which is need to be deleted, the first element which needs to be deleted. At that point of time, that would be the element which has to be deleted. So front would be pointing to the first element in the queue. I'm not saying first element means the 0th element, whichever is the element going out. Like for example, in the location 3 and 4 and 5 I have elements, so front would be pointing to the location 3 and rear would be pointing to 5. So at that point of time I have 3 elements, so I need to point from the location to which front is pointing to the rear location. That will give me the elements of my queue. I is equal to front I less than or equal to rear I plus plus, right? Cout queue of I \t, give a tab space between the elements and then close it. So my for loop is done and then my function also is done. So this is my print function which prints the element of a queue at the given point of time. Like whenever I say, for example, there are 5 elements in my queue, then I delete 2 and then call the print function, it will show me the remaining 3 elements. Then I'll delete one more and again call the print function, it will show me the 2 elements. It has to show me the elements whenever it is called. At that point, what are the elements present in my queue? So I have I have written the definition of defined all the functions which was declared inside the class. Now I need to write my main function, because without main my program will not work. So how do I start that? Void main. So clear screen. Then let me create an object first, because without an object I will not be able to access the members of the class or the data of the class. And when you create an object, memory would be allocated to the class. So how do I create an object? The general syntax is the class name space the object name. What is the name of the class? Q, and let me say this be the object name. It's a user defined name. You can choose whichever you want. Then I will have an integer variable. I need to have an integer variable, right? Because I need to take it from the user and then pass it as an argument to the enq function when you're inserting. So it is of type integer. So I'll say item, comma, let me have one more integer variable choice wherein I will take in the user's choice to perform the operations like all the Q operations. I would be printing it as a menu to the user and the user can choose which operations he or she wants to do. Then char ch is equal to y. So what does it mean? It means that this is initialization and declaration and initialization in one step. Yesterday, many people had a doubt that they can use yes, yes, or no over here, wherein you cannot, because yes and no would form a string, and I'm talking about a single character. Double equal to, that is the relational operator I can use with a single character, wherein the ASCII values are compared, whereas a string cannot be compared with a equal to, that is double equal to. With a relational operator I cannot compare two strings because yes or no, no is again two characters, more than one character becomes a string, and then I cannot compare it with a double equal to. I need to use a string compare built-in function, or you need to extract it character by character and compare it, which doesn't make sense. Y or n, the user can easily understand that, so you don't have to complicate it further. So char ch is equal to y. I am giving it as a lowercase y, and C++ is a case sensitive language. So if I say y as a user, for me uppercase and lowercase y does not make any difference. Like if I have to say yes, uppercase y also means yes to me and lowercase y also means yes to me, whereas for the compiler it's not the same. So I will convert whatever the user enters, whether it's in the uppercase or the lowercase. As long as he enters a y, I'll convert it into lowercase and put it back to ch, so that when the variable goes to the while loop header, the comparison would be easy, like the condition would be satisfied as long as the user has entered while. So after that I need to put it in a loop, because I would be running this as I won't be putting it in for loop, because I don't know how many times the user would not want to execute it, because for loop is a fixed loop, wherein before that you need to know how many iterations the loop is going to run, whereas as a user I may prefer to run it 10 times, 5 times, 3 times, only once. So you have to use a while loop wherein the user can decide whether he wants to continue or not. So I'll say while. This is an entry control loop, because while entering the loop itself, the condition is checked, and if the condition is false during the entry, it will give you an error message. While ch is double equal to y. Until this is true, the while loop will execute. Okay, so let me say cout 1. This is the operation I'm going to do if the user presses 1. The next is cout 2 dq enter. If the user chooses to delete an element, I would be performing the dq operation. Next is cout 3, that is print. And next is see out. 4 is exit if the user wants to exit the application. So this is the menu. As a user, I will every iteration of the while loop, this menu would be printed to the user to choose from. 1 is insertion operation, that is NQ. 2 is deletion operation, DQ. 3 is print, which will print the elements of the queue at that load point of time whenever you call it. And 4 is exit, wherein you can exit the application. After that, what I need to do? I need to ask the user to enter his choice, right? See out. Enter your choice. So after that, I need to what? Which is the variable? Its choices 1, 2, 3, 4, 5, which are integers. So I have an integer variable called choice. So C in choice, right? After that, see in choice, what will I do? I need to see. This is again multiple selection statements. I have multiple selections, like I can choose 1, 2, 3, 4. So anything I choose is a correct one. It is not like only one. So I will use multiple selection statement switch here. What is the syntax of switch? Switch is in lowercase, and then which variable does it take? Which expression? Choice takes multiple, then pass it as an argument. Choice, open the braces, then case 1. Case 1. This is the syntax you need to follow. Case space, the first value of choice, which is the first correct value of choice, is 1. So case 1, and then if I choose NQ, what should I do? First I need to ask the user to enter an element to be inserted into the queue. Take it in the variable item, because I have declared item as an integer variable over here, and then call the function NQ and pass item as an argument to it. This is what I need to do. So see out, enter the element to be inserted into the queue. Okay, enter the element to be inserted into the queue. C in item. After that, I need to call the function NQ using an object of the class Q. What is the object I have created? QOBJ dot NQ, and then item is the parameter or the argument passed. Then break. Getting it, enter the element to be inserted into the queue. Then see in item. So here QOBJ. QOBJ. When I create that, the Q function constructor would be run, and the rear and the front pointers would be assigned with the value -1. That is why I'm not calling that. When I create an object, automatically it gets executed. So here I have QOBJ and I'm calling, this is the function call. After that, break. This is case 1. Suppose I call the DQ function, then what happens? I need to just QOBJ dot Why do I not take in any variables here? Because DQ, I'm not passing any arguments to it. I'm just calling it break. Okay. Then the case 3. What is the third case? If qobj.print, because if I want to print, then I need to call that function dot print, and I'm calling that function break. Hopefully you're making a note along with me. Then what is the case 4? Case 4 is nothing but the exit function. So I'm calling the exit function and it will exit the application. Exit function is written in process.h header file. So that is why it's a built-in function, built-in library function. I have included the process.h header file, otherwise it would have given me error. After that, if none of this is true, like anything apart from case 1, 2, 3, 4, did I do, if I choose anything apart from that, what will happen? So you should write it in a default statement stating that if anything of this is not true, it means that it is not a valid choice, correct? That message should go to the user. If you have not chosen, then it's a wrong choice. So I will write it in default. Default case will not come, only default will be there. Default, if none of this is true, the user chooses 5, 6 or any other number apart from 1, 2, 3, 4, then it will go to default cout endl not a valid choice, right? It's not a valid choice, and then this is the end of my switch. So I'm ending my switch here, where in case 1 I am taking the user to enter the element to be inserted into the queue, taking in that and calling the enqueue function and passing the item as an argument to it. In case 2, again I am calling the dequeue function, but then I don't need any arguments over here. The third, I'm calling the print function, wherein it will print the elements present at that point. In the fourth, I will call the exit function, which exits the application. And in default, I have cout endl not. It's not over here. Not a valid choice. That is, you have not had a valid choice endl. So that choose properly. And this is the end of my switch. But still, I need to write it. I haven't closed my while. I need to ask the user, like, this is one time of that. Do you want to continue? That is, do you want to perform one more operation? So cout, do you want to continue? Yes, no, right? So cin ch is equal to lower ch. Fine, I'm converting whatever the case the user entered into the lower case. Like, do you want to continue? If yes, take in that ch, whatever choice the user enters, ch is equal to 2 lower ch. Then I will say if ch is double equal to y, then continue. Well, continue, what will happen? Whenever continue is encountered, it will leave the remaining statements in the loop and it will go to the header of the loop. The control goes. So if it is not true, then end of queue operations. So I will say end of queue operations and I will close my while over here. Are you getting it? My while is closed over here and then get ch and the end of my main. So this completes my main also. So in main, what am I doing? I'm creating an object, then variables, then I'm having a variable ch is equal to y as long as the user wants. The answer of the user is y. This menu would be displayed to the user for every iteration of the loop. Then enter your choice, C in choice, switch choice. If the case 1 enter D, you are calling the enqueue function. If it is choices 2, that is delete, you are calling that. Choices 3, you are going to print. Otherwise, you are going to exit, not a valid choice. Then do you want to continue? Yes or no? See in choice, then I'm converting that to lowercase and storing it back in ch. If ch is equal to y, continue. So this will not get printed because continue will not run this, it will go back to the header. Otherwise, if ch is not equal to y, it will say end of queue operations. This is the end of my while and get ch end of my main. This is the end of the program. Hopefully you have understood it and we will be doing the algorithm in the next class, but I want you to try writing it. So homework is write an algorithm to perform DQ operation. So hopefully you have understood today's class. Take care, stay safe, see you tomorrow, or I can say see you on Monday. Bye bye.